Okay, well, thank you. Thank you all for coming to this symposium on embodied agents in contemporary visual arts. I'm sorry I can't be there. I'm, as I said, here in person, here in Boston. My name is Paul Cohen. I am a professor of computer science at the University of Pittsburgh, and I'm also the trustee of the Harold Cohen Trust. And in fact, I worked on embodied cognition in the 1990s. I'm an AI researcher. I worked on embodied natural language semantics for robots. And although I'm not doing that anymore, I'm still pretty sure that being born into a physical world and growing up with physical beings creates a kind of intelligence that's quite unlike that of modern AI. Today, though, I'm going to talk about ideas from embodied cognition in the art of Harold Cohen and how those ideas influence the evolution of the Aaron program. The term embodiment is a bit confusing because, as the philosopher Mark Johnson pointed out, embodied cognition is about what's happening in the mind and what the mind owes to the body. In art, embodiment might mean any number of things. It might mean the physicality of the art itself. It might mean the physicality of the machines that make the art and the boundary between human and robotic art, as we just heard. Or it might mean the mental operations of those machines and what those operations owe to either human physical bodies or the robot's physical body. Now, in Harold's case, he definitely wanted his art to have a physical manifestation. Partly that was because he was a classically trained artist, and artists make paintings to hang on walls, but also because he recognized a relationship between physicality and intentionality. And I'll talk more about that in a minute. So he built physical machines to make art. Unfortunately, viewers were much more interested in the machines than in the art. And that really annoyed him a lot. So eventually he stopped exhibiting the machines. Incidentally, in 2024, we had a retrospective of his work at the Whitney Museum, really glorious exhibition. And we made the mistake of having two plotters running there. So even in 2024, people are more interested in the machines than in the art itself. It's kind of a problem. Anyway, the interpretation of embodiment in philosophy and linguistics and psychology, in which the mind is shaped by the body, was very important to Harold. And I'm going to give you three examples. Here you see work from three decades, the 1970s, the 80s, and the 90s. And the point of this slide is that Aaron's evolution was relatively slow until 1980. That's the middle row, when Harold invented a simple drawing method, which was to pose a kind of invisible skeleton and then draw a line around it. And he called that embodiment. And after that, Aaron experienced a kind of Cambrian explosion of forms. But actually, his engagement with ideas about embodiment started quite a bit earlier, around 1970. In 1968, when he first worked with computers, he insisted that Aaron's lines should look like they were made by human beings. He thought that nobody would view images as art if they were composed from straight lines or splines or other mathematical curves. He thought that viewers would want to recognize a human hand and human intention in art. And I suspect this is why some modern digital artists use robots, as we just heard. The physical stroke provides a signal of intentionality in a way that screen-based art really cannot. Now, one way to convey intention is to show continuous adjustment to perturbations in the pursuit of a goal. often physical perturbations in pursuit of a goal. And Harold called that feedback. When a human draws a line, its endpoint is the goal, and the perturbations are due to our bodies, specifically our imprecise muscular skeletal system and our hand-eye coordination. We don't draw perfectly straight lines because we don't have the bodies for it. Now, the problem is it's easy to make machines draw straight lines, but how can they be made to draw human-like, seemingly intentional lines? And that was the problem that Harold was facing in the very late 60s, early 1970s. And he came up with what he called the freehand line algorithm, which mimics human embodiment by deliberately injecting perturbations into the line drawing process. You can see an exaggerated trace of the algorithm at work in the top of this slide. Each circle is an opportunity for Aaron's hand to wander just a little bit. And the brown line shows the result. In effect, the algorithm deliberately throws itself off course in order to correct itself and thereby convey the sense of intention that comes with feedback-controlled processes. If you want to, you can play with the algorithm yourself at the website down here at the bottom. I put this little app together, and this was for an article I wrote for Right Click Save, which you can see cited on the slide also. But you can play with the parameters of the thing and see that you get rather different kinds of lines. So it was a very versatile algorithm. I don't think Harold was particularly interested in all that versatility, but he was very interested in having lines that were clearly not made. Well, they were made by machine, but they clearly did not look like they were made by machine. Anyway, let's move on from that. Okay, so if you watch a robot move from one point to another in space, or a plotter move from one point to another, you will of course attribute intention to it. This is one thing humans do, right? We attribute intention to things that don't have intention. You'll attribute intention whether or not feedback is on display, as it is in the freehand line algorithm. And so what that means is that feedback is not a necessary condition to convey intention, but it is a sufficient condition. The lines appear to be intentional because they appear to be embodied. They appear to be self-correcting. Throughout the 1970s, Harold was influenced by Native American petroglyphs or rock art, like this one on the left from the Chalfont Valley in California. He was struck by the fact that these images appear intentional when we have absolutely no idea what the artists intended. And he called this attribute evocation. It's the ability to evoke something in the mind of the viewer. And again, here he was guided by principles of embodied cognition. He reasoned that if the images can evoke across cultures, sometimes across centuries, then the evocation must arise from how we perceive the images. And he quickly realized that even human infants can discriminate between figure and ground, between open and closed forms. They can recognize repetition. They can distinguish between ballistic and animate motion, and a variety of other Gestalt principles. And so in the 70s, he was programming Aaron to appeal to these perceptual primitives, as you can see in the drawings on the right. This phase lasted about 10 years, from the 70s to the early 80s. It was the foundation of some spectacular work. This is a canvas about 17 feet wide. This was a commission at the headquarters of the Digital Equipment Corporation. You can see Harold sort of down there in the on that little scaffolding thing, painting them. Again, pretty big, pretty large. He showed at the Tate, San Francisco Museum, variety of other places. sometimes just the images themselves, sometimes physical plotters making the images. However, he thought that he was running out of embodied perceptual primitives for Aaron. And he was also concerned that the drawings lacked visual variety. There was a kind of family resemblance about them. They all looked sort of more or less the same. Then in 1980, a colleague asked Harold whether Aaron could draw something real, like an animal. And Harold was eager to oblige, in part because he was consulting to these people. And he asked himself how to make a drawing of an animal, because he hadn't done figurative drawing since he was in school in the 50s, and he wasn't really sure where to begin. He started by having Aaron draw an internal skeleton and then using the freehand line algorithm to draw around it. And these were, I think, his first results. They're certainly the only ones that have survived. Harold was amused by the evident resemblance to European cave painting, to such an extent that he even played with having little human-like forms, as you see on the bottom right. But the real gain came from this drawing strategy and from the affordances of skeletons. Skeletons exist in space. They can be viewed from different angles. They can be posed. They can be clothed in different bodies. And as Harold says in this article, they afford geometrically complex closed forms without requiring geometrically complex descriptions. And so this embodiment strategy was a winner. You just draw the internal skeleton, then you draw around it. And from that point on, really until the last years of his life, all of his images were made in this manner with the freehand line algorithm. So, for example, in 1982, we have pictures like this that we're showing, I think, at the Tate and the Arnolfini. You can see sort of in middle horizontally on the far left, something called an enclosed fence, where you have a fence-like skeleton and then a line drawn around that fence. There's another one in the middle down toward the bottom. Sometimes the fence or the skeleton would be drawn without an enclosure, as in the sort of gray and pink figure in the middle. Later in 1982, you don't see the skeletons at all, but all of these figures have skeletons. They are rock-like things, sometimes capped by biomorphic forms that had appendages. A little later in 1982 is a good year for Harold. A little later in 82, we see these towers of rocks, again with appendages and also with these kind of leaf-like forms showing up. By 84, these towers begin to look vaguely like humanoid mushrooms. The earlier appendages might now be read as arms. They might be read as having fingers. The edge shading on the rocks starts to migrate inward and look vaguely like facial features. And then by 1985, we have the picture you have on display there in London at the Symposium. It's from a generation called Early People that was prepared for display at the US Pavilion at the Japanese World Fair in Tsukuba in 1985. You can see that the forms still don't have legs or feet, but they do have eyes and noses, and they're interacting with these sort of vaguely rock-like things, and shading has sort of become stippling. I also really like the pictures on the right, which were taken by Harold's wife, Becky Cohen, at the exhibition, mostly because it makes me think, how old are those kids today? That's 40 years ago. And they must be all grown up, and they must have been some of the first people to see robots making art, which is kind of exciting. The 200th anniversary of the Statue of Liberty in 1986 provided an opportunity for more overtly human-like forms. The animals, which had been enclosed by a single outline, gave way to a much more sophisticated drawing strategy in which the body was made of parts. Again, there's an internal skeleton, but those parts get fleshed out individually. What you can see on the right is a study in arms, because that was one of the parts that would be assembled in a body. Fortunately, he didn't have to worry about legs because, as everybody knows, the Statue of Liberty has no legs. But he continued to work on skeletons throughout the 80s and the early 90s. At one point, these skeletons got really sophisticated. You can see on the right, he had actually mapped out all of the points on the head that he needed in order to articulate expressions and so on. I don't think he was that interested in drawing people. What I think interested him more was the challenges of composition that arise when drawing any recognizable figure, and also the evocative potential of interactions between figures that look like people. So he worked really hard on pose and on facial expressions. And whereas the freehand line algorithm and the perceptual primitives for rock art are clearly inspired by the principles of embodied cognition, this skeleton-driven strategy approached embodiment at a different scale. If you have a body, where should it go? How should it be posed? How should it interact with other bodies and with plants and rocks and so on? So if you'll let me conclude with a fanciful analogy that I think is apt for a symposium on embodiment in visual art. Approximately 560 million years ago, before even Harold was born, the diversity of life forms on our planet just exploded. It increased dramatically. This was called the Cambrian explosion. And the world saw a very rapid evolution of sponges and tube-like plants and animals with bilateral symmetry and various kinds of external and internal skeletons. Now, the Cambrian explosion was not driven by the evolution of internal skeletons. Rising oxygen levels, the calcification that those afforded, and predation were much bigger drivers. But it's undeniable that Aaron's Cambrian explosion, the sort of explosion of forms that happened at the beginning, from the beginning of the 1980s, absolutely were driven by Harold's embodiment strategy of drawing a skeleton and surrounding it with a body. So thank you very much. If we have time for questions and comments, I'm very happy to hear them. Thank you. I actually can't hear anything. Oh, you have the thing turned off. That's right. I can hear you now. Yeah. Thank you. Oh, yeah, of course. Yeah, that's great. Thanks.
Now we see you full size. It's small enough. Question.
Yeah, can you hear me?
Can you hear
I
me?
can hear you, but you'll have to speak loud.
Okay,
Thank
sure.
you.
Yeah, so I was just wondering about the process. So you described these skeletons and then the lines being formed around them, but I was wondering how, like, where the skeletons come from, if they were created by an algorithm or if that was manual or some other process.
It's a great question. Aaron knew how to draw skeletons, so um, figures were posed by Aaron, expressions were generated by Aaron, the composition was all done by Aaron, but what constituted a skeleton was built by Harold. So actually, the skeletons went through many generations, some of them involving just a few lines. But in the pictures I was showing at the end, they were really complicated. A skeleton had a whole lot of moving parts, but the parts were but how they moved and how they were posed, that was all done by Aaron.
Great, thank you.
Yeah. Yes.
Hi. So I was always curious. Was Aaron like you would describe it more as a library, or was it an application, an actual application that was consistently developed since the 60s, or it went through iterations? I don't know if my question is clear.
I'm sorry, I only heard part of that. Did you
No, so
ask
I'm
is
asking
Aaron a
it like if you could describe Aaron. So is it like an application that Harold developed over the years, or you would see it as a library of functions to do those drawings? And how?
Oh, I see.
Yeah.
You're asking about how Aaron was implemented over the
Yes.
years?
Yes. Yes. Uh,
Is it
Oh my God.
an evolution like Microsoft Windows, like you keep updating,
yeah. Yeah. Yeah.
was it at some point you trash everything and you start with something completely
No.
new?
Yeah.
Yeah, that's a great question also. I don't think Harold ever used the word evolution, and I only used it in this talk to be provocative and to sort of draw an analogy to the Cambrian explosion and the evolution of human life forms. But to answer your question, Aaron was a continuous project. Nothing was trashed. Um, and one of the problems we have in the trust is that there are dozens and dozens of versions of the code, each of which is only slightly different from the one that came before it. Some things were so important to Harold that he kept them pretty much unchanged for over 40 years. And one of them is the freehand line algorithm. That algorithm he knew he was onto something in the late 60s, early 70s. And that painting behind me is made by that same algorithm. It served him for a really long time. Yeah, it's more like Microsoft Word, except it's actually pretty good.
Nice one. Yeah, thanks a lot. Yeah.
Thank you.
Thanks for a great talk, Paul. So Harold's rules were used for drawing, like if you meet a line, lift pen, meet another line, drop pen. What about the rules with color? Was he using rules to define the colors or not?
I, I'm laughing because I've been working on a kind of a LLM enabled biography of Harold, sort of a digital archive LLM enabled biography. And the one thing that the LLM consistently screws up is Harold's approach to color. Uh, and there's a good reason for it. Harold approached color several different ways, and LLMs can't tell them apart. And so, believe it or not, I've been working on this problem for about 6 months now, which is why I'm laughing. The first real manifestation of color was in the first real manifestation of color that people saw was the painting machine, and that was rule-based. It was an expert system. And that worked for about 20 years. For 20 years, he just had a whole bunch of different rules that sort of embodied his understanding of how to make color. And in those rules, brightness was the more important aspect of color. Hue was not important. The machine would sort of do what it liked with hue, but brightness and the control of brightness was super important. And that went on for, as I say, 20 years. The rule-based system got to be very long and very cumbersome. And he found that, as everyone does when they build expert systems, you change one rule and everything else sort of falls apart. Also, he switched from RGB to HLS as a coding scheme. And one of the reasons he did that was HLS let him have gray. And it's really hard to get gray when you're using RGB. But before he finished coding all of those rules, recoding all those rules for HLS, he had this sort of insight about a completely algorithmic way of doing color. He tells the story of sort of waking up one morning and thinking, why don't we do it like this? And because it only took sort of an hour to implement, he gave it a try, and he was astonished by the results. So this was a weird algorithm that depended entirely on relationships between colors, not brightness at all. He never looked back from that. But there's an interesting point to that story, which is that I think it was Harold's first realization that machine intelligence won't necessarily be like human intelligence. You know, his rule-based coloring scheme was very much a model of his own expertise. This algorithm that he came up with was really perplexing. He couldn't figure out why it was doing such great color. In fact, he couldn't even figure out what he'd wrote until he went back and he looked at the code again and again and again. And every time he wrote about this algorithm, he had to go back and look at the code. And he wrote quite extensively about this realization that machine-based color would not necessarily look anything like human-based color. And that's, I think, a lesson that we have all learned as we've moved into this brave new age of artificial intelligence. Machine intelligence is really nothing like human intelligence.
Thank you.
Yeah.
Thank you again.
Okay, thanks a lot. See ya.